Let's knock out a couple of proofs here dealing with the parallel lines. First one, given that line Q is parallel to line R, we're going to prove that 1 is congruent to 3. 1 and 3, whoa, not sure what happened there. 1 and 3 are actually alternate exterior angles. So actually what we're doing here is proving the alternate exterior angle theorem. So we're going to pretend like we don't know alternate exterior angles are congruent, and so we're not going to use that line in our reasons here. So let's approach this here. Like I've said 100 times here, the first line here, as long as those match up, that should be given. Okay. Now 1 is congruent to 2. Let's look here at the picture. 1 is congruent to 2 because you have vertical angles. That's the vertical angle theorem. The vertical angle theorem states that if the lines if the angles are vertical, then they are always congruent. Okay, next we have 2 is congruent to 3. And as long as angle 2 and angle 3 are touching the parallel lines, which they are, if the lines are parallel, that means those are congruent angles. And that's called the corresponding angle theorem. Okay. Now, if 1 is congruent to 2 and angle 2 is congruent to angle 3, we can jump to this conclusion that angle 1 is congruent to angle 3 right there. Now, like I said, you can look up there at the picture, but those are technically congruent because of our logic order that we're doing, and that's called the transitive property. Okay, most proofs will use transitive property or substitution at some point. So that's that. Moving along here on number 47 here, you're starting out with some lines being parallel, and then we're going to prove that some other lines are going to be parallel. It's kind of like the one from your quiz here. And a couple of things we'll say here about this, but we'll get to it. So A is parallel to B. That was given to us. And then they're also saying 4 is supplementary to 13. Let me mark those. They're not necessarily congruent, so I'm going to mark them differently, but I'm going to maybe do a double hoop right there. So 4 is supplementary to 13 right there. That was also given. Sometimes we'll give you two things. Feel free to write them both. Okay. Now, apparently 4 is congruent to 12. Let me go and figure out why that is. There's 12 right there. Now, 4 is congruent to 12 because they're touching the parallel lines that we're starting with here. 4 is congruent to 12. So those are corresponding angles again. So we'll say the corresponding angle theorem, which states if the lines are parallel, the corresponding angles touching them are congruent. Okay. Now we also have 12 is congruent to 16. Here's that angle right here. 12 is congruent to 16 because those are actually vertical angles. So let's go ahead and say that's the vertical angle theorem. So if 4 is congruent to 12 and 12 is congruent to 16, we can jump to the conclusion that 4 is congruent to 16. That one where you jump to the conclusion is the transitive property. Now this one's kind of weird. I don't know if we've seen one exactly like this, but I'm sure most of y'all will be able to track this logic here. So if we have 4 is supplementary to 13, and then 4 is congruent to 16, then we can say 16 is also supplementary to 13. One thing you can write here for this here is the substitution property, like we're just going and swapping that out. It's also kind of like an extension of a theorem we talked about at one point in the class. It's called the congruent supplements theorem, and that's saying, if two angles are supplementary to the same angle, then those two angles are congruent. It's kind of, I guess, the converse of that, really. But anyway, substitution is probably good there. You're just swapping that angle 4 with the angle 16 there. So that's your substitution property. And now let's go and look. We kind of have a lot of things highlighted, so let me change colors here. And now we're kind of looking here at 13 and 16 right there. And those are same side interior angles. And that, since those are supplementary, is going to get us this last step here. So if those angles are supplementary, that proves that those two lines that they're touching, which is C and D, are parallel. This is actually one of our converse theorems. Usually when we end with something being parallel, usually we want to add converse at the end of this. One of the converse or the opposite, flipping the order of the statements right there. It's one of those theorems. So this is called the same side interior angle theorem. But this one's a converse because you're going from supplementary to parallel, as opposed to earlier when we went from parallel to supplementary. Okay, so that is that right there on that proof.